OK. Well, hopefully, I'm going to show you a blueprint for PHP dev environments that makes it just as easy for PHP, hopefully. So this is where we're going to get into the meat of it. So we need some tools to start off with in order to build our dev environment. There's a little bit of work to do up front to get everything up and running, and then you can just set environments up to your heart's content. So the first thing, of course, we need is Docker. And you can always get it from Docker's website. If you use a Linux distribution, don't use the packages they ship, go and get Dockers. Docker are very aggressive with their updates. Their updates are always timed in and around their conferences. They're very much that startup, marketing-driven delivery focus at the minute. I'm not saying their technology is not solid, but they do line everything up for their DockerCon and all the big announcements they do. So go and get stuff from the source there. You need Docker Compose. It doesn't have a logo, so I can't put it up there. Now, if you download Docker for Mac, Docker Compose ships as part of that. If you're on Linux, you've got to go and get it separately and install it yourself. And then you've got to remember to update it, which is something I'm very bad at doing. Goodness knows how old my Docker Compose is on my main dev machine. I probably haven't updated it in a year. But if you have Docker for Mac, it comes with it. It's easy. We're going to create a network using Docker, and I'm going to show you how to do that. You're going to need a tool called DNS Mask for doing domain name resolution. Is anyone familiar with that? Used it? A couple of people? Awesome. Of course, we're going to need some containers to actually put into our dev environment. My containers are all generic, even though I use them with my clients. There's no client-specific stuff in them. So they're actually up on Docker Hub for you to download and get. There's no docs or anything with them. You'll have to read the Docker file and see how they work for now. And if you do use them, you'll be the first people who I know are using them. Although the fact that some of them have got 600-700 pulls suggests it ain't just me using them. Because I build an environment and it stays built. I don't rebuild them every day or anything, so it ain't me doing 600 plus pulls of them. So someone's using them, but I don't know who they are. And you need some apps, but that's on you. You have to provide the PHP apps to run in this environment. Just want to give a shout out to Stefan Scoop on Twitter. Ever get the chance to see him speak at a conference over here, do go. And that's the name of his company. He runs a Dutch development company. I'm not going to pretend to pronounce it. Not my skill set. But yeah, apps, they're on you. You've got to provide those. These are the steps we're just going to run through. I'm going to show you in detail each of these steps in order to build a dev environment. So the first step is we're actually going to put our dev environment on a network. We're not just going to run it via port mapping, which is what you may already be doing with Docker, I expect. So can anyone guess why I'm saying always do this? Yes, please. Because they're not exposing the ports. That is true. The Docker networks are entirely private. No one outside your host operating system can see them unless you put a proxy in place. They're completely virtual networking inside your machine. So that's one thing. Can anyone else think of a reason why?
Keep each environment isolated.
Exactly that. Keep environment isolated. We want our isolation again. Maybe that does work. Yeah, we want our environments isolated, but also we want our environments representative. Production environments rarely run everything on a single node. You're normally deploying multiple AWS images if you're on Amazon Web Services or equivalent. You're normally consuming, you've got your database server on one box, you've normally got your web server on a different box, and normally you've got several of those to scale out. So we want things to be representative. And in production, everything talks to each other via networks. So we want to recreate that on our dev machine. So if we've got any code that's cheating and doesn't actually work when you talk to it over a network, we want to find that when we're developing it, not when we ship it and all the tests fail. And yes, I have seen that happen. It does happen. So we're going to run a command. And this is a command to create a network. And you're going to run this on your host operating system. And it's going to create a network inside Docker. So this is a virtual network. It doesn't exist on your actual LAN that you're connected to via Wi-Fi or via tethered or anything. It needs a name. And I recommend that whatever name you give it, I'm using AppDev throughout all these examples, it's going to use whatever you're going to call the top level domain of your URLs you're going to resolve to. So imagine www.appdev is where I'd point my browser to view the website in this environment, for example. Whatever you're going to give that top-level domain, make your network the same. Because if you start building out multiple environments, it's an easy way to remember which environment goes where. Okay? This can be any top-level domain. You can't use dev anymore, if anyone does, because that's actually Google's. And they've, in Chrome, the latest Chrome update is starting to stop you using that for your own devices a little bit. So you've got to make one that doesn't exist out in the real world. It needs an IP address range. So this will be what's called a private IP address range. And you'll need to look at what networks you join, what VPNs you use, and what IP addresses they assign. You need to pick something that's not going to clash with the world you work within. This is the one that I'm using for my main dev environment today. But I know some VPNs do fall in this range. So you need to go and pick one yourself. And when you run this command, you get yourself a nice network. It's sat inside Docker. The rest of the world can't see it. But this is a one-off piece of work. Once you create that network, it's there until you delete Docker or delete the network if you choose off your machine. So it's one piece of setup you've got to do, and then you've got a network you can start attaching things to. Yes, please.
Why would you not just put that in Docker Compose?
Why not? I'm going to show you why in a minute. Because, actually, I'm going to show you why in 2 minutes, because we want one more step first before we do that. Let's introduce everyone to Docker Compose first, and then we'll come back to that. So we've got our network, and we want to put something into it. Now, my projects don't tend to live in a single GitHub repository. There tends to be multiple apps, each with their own GitHub repository. So I tend to have a top-level folder that I then check out each of my apps underneath. Okay? And this is the structure I'm going to show you today. And so at that level, where I check out my apps, I create a folder to hold the runtime information for my Docker containers. And so it's easy for everyone to remember what it is. I call it Docker dash and then the name of the network that's going to have all the config, it's going to have all the config for. And inside there, I stick a config file called dockercompose.yaml, which is going to tell Docker what we're going to put on that network, what's going to be in our dev environment. And for some projects, I will have multiple environments. I'll have a dev environment. I may have a test environment that's updated a lot less frequently. And if I'm doing pre-sales work, I'll have a demo environment as well. So I'm not going to break anything while I'm doing my dev, and then a phone call comes in, we've got a client, can you do a webinar in half an hour? And then scrambling to put everything back to make it work. And I've got a demo environment that's all set up, ready to go. It's just preparation up front, and just life's a lot less stressful, I find. So but we're going to focus on this dockercompose.yaml file. And I deliberately stick it inside a folder for that network. If you can't see that clearly from there, the slides will be up online tomorrow morning at the latest. But what we've got here, this is YAML. Doesn't matter how you feel about YAML, that's what Docker Compose uses, you just have to get used to it, I'm afraid. And we define a set of services. We've got one service here, and we tell it which networks we're using as well. And we're defining the network as external, as in predefined, very deliberately. I'll show you why in a bit. And so this is a container you're always going to want to put on your network. It's called Network Lead. You just download it, and when you start up Docker Compose, and it will just run for you. But it needs somewhere to write log files to. So we're going to have to create some folders. So here's our structure. And inside our Docker AppEnv folder, we need to create 3 folders underneath there. One for config, one for data, one for logs. And you'll find this is a pattern that repeats over and over with well-designed Docker containers. That they need you to provide some volumes, in Docker language, for them to write to. And for you to inject config as well. Now, for Network Lead, all we actually do is we want the logs to write out to disk. We don't have any config to inject today. So we use the volumes command here, and we say the logs folder inside the Network Lead folder, just mount it into the image. And what this does, this takes a folder on our host operating system, and it makes it look like the folder /logs inside the container. So the container is pre-configured to write its logs into /logs. And it doesn't know where that actually is. It just thinks that's it. It can't tell. And they're actually appearing on our host operating system. So from the host operating system, you can watch the logs, you can see them, and they still exist when you destroy the container, which is the main reason we do it. Very simple stuff, honestly. So we start it. We start our container. Now, how do we know that that's the name of the container? Because in our services list, I don't know the correct YAML term for it. I'm not a YAML fan, so I know as little YAML as I can get away with. Mostly because of the hours and hours and hours I've spent debugging production problems because of YAML issues. So I use it very, very reluctantly. I'd rather use something like JSON where you're going to get burned a lot less.
Do you know JSON is technically valid YAML?
I know, yeah.
So you could actually use JSON in the YAML file?
Yes, you could. Maybe I'm going to start doing that. No, seriously. One reason not to do it in talks, though, is because all the documentation online shows this sort of syntax, but I like that idea. I don't think the Docker guys, I'm not sure, too fond of me anyway, but I like that, yeah. That's got mileage. But anyway, yeah, under the services, Docker takes the name of the container. This has nothing to do with its name on the network. How can I put this? Naming things in Docker has grown organically from its very beginnings, shall I say. And you learn the hard way what goes where and how you've got to be uber explicit with it to make sure there's no surprises. But that's where the name comes from there. So we start it, and we've got ourselves a container. It's up and running. Network lead is now up and running on our network. And because it's the first thing we start, and this is important, it gets an IP address on our network ending in 02. 01 is reserved for Docker. It's its gateway for providing bridging to the outside world, etc. But there you've got 02. And that's where our network lead is. And from your host operating system, you can ping it as if it's a server somewhere. Your host operating system can't tell the difference. So that's how we get our first container up and running. Now, I actually told you what that container is and what it does. But I'm going to do that now. Because what we really want to do is get DNS working. We've got our container running on our network, and we can ping it via its IP address. But I don't know about you, but I don't memorize IP addresses and ping them all the time. Even on networks I own. I don't do that. I ping names. Every tool I use takes names. In fact, from time to time, I come across tools whose validation for their config files or their dialog boxes won't even accept an IP address. But they always accept names. So we want names. Names are friendly. Numbers are not. So we want to be able to ping that from our host operating system, but we can't at the minute. And this is where DNS mask comes in, because for some reason, Docker itself has no built-in DNS support. It doesn't provide a DNS server for you. I am baffled as to why. I don't understand it. Docker knows the names of everything on its networks. It knows their IP addresses, but it doesn't provide you with DNS services so you can query them from the outside world. I don't know why. I've never asked them, to be fair, so I don't know what their answer is. And I've never seen it written down anywhere. So we have to bridge that ourselves. Now, to do that, we have to set up what's called multi-resolver operating system support. Because we want our host operating system, which is where we're going to run all our tools, because it's nice and fast and has a decent desktop. We want all our tools on there to be able to send DNS requests to our DNS server or to the internet's DNS server, depending on our domains. Because there's no point querying your company's DNS server or your ISP DNS server for your private network inside Docker on your machine. It will never have heard of it. And if you're really unlucky, you've picked something that it has heard of that's got nothing to do with your stuff, and that thing can get very interesting. So we have to get multi-resolver operating system support working first. Now, Ubuntu 16.04, which is their long-term support version, that works already. We don't have to do anything. It's fantastic for that. No action needed to get the operating system side of things sorted. Unfortunately, I think it was in 1610, but I skipped that. Certainly by 1704, they've broken that. It no longer works. So you have to actually go back in and put all that back yourself. And there is a page on the Ubuntu wiki to show you how to do that. But what happened is systemd all the things got to DNS. And systemd is now your DNS resolver on Ubuntu. I have no idea why. Absolutely not. But there again, that applies for most of the things systemd does, one could argue. So you've actually got to go in and reconfigure the Ubuntu to go back to using Network Manager to do DNS resolution. But there is wiki pages on that. And OS X, MacOS as it is now, also gives you multi-resolver support. If you use a different Linux flavor, you'll have to see whether systemd, all the things, has encroached too much on that as well. I don't use Fedora or Red Hat or CentOS anymore, so I don't know. And we've already established there's no one here who uses Windows, so I don't have to worry about that. But once you have got it working, here's what you do on Ubuntu to tell Ubuntu about your private network's DNS server. And we're coming on to the point about why we have our network defined externally to our Docker Compose file. You're going to drop a file into that folder there on Ubuntu. I recommend that the name of the file matches your Docker your Docker network so that it all lines up. It's easy to remember, but you don't have to. Ubuntu doesn't care. DNS mask on Ubuntu doesn't care. And inside it, you just put one line. And this is why we define the network externally. We'd say for the top-level domain app dev, go to that IP address, which happens to be our network lead container. But we're putting this, a static config, in the host operating system. That's why we define the network externally, so we've decided the IP address and it's fixed forever. If we put it in Docker Compose, certainly the version of Docker Compose I have, you can't assign an IP address. Can you now? That's good to know. I'm using 1.7 maybe. Really old. Really old. That one I don't believe could do it. But that's why I do it, because if I've defined the network externally, I'm putting a static IP address in my host operating system config, then I know everything's going to work. I don't have to worry about anyone messing up that Docker file ever. That's why I do it. And that IP address is the IP address of our network lead container, which is running DNS mask for you. I've already packaged it up and given it the config needed for it to know what's going to appear on that network. So as we add more containers on there, DNS will automatically work for you. Now, one thing with Network Manager is even restarting it is not always enough for it to pick up configs reliably. The best way on Ubuntu, unfortunately, is to reboot the box. It's like going back to Windows. But this is one of those times where reboot is actually the thing that's 100% foolproof. Yeah, that's how you do it on Ubuntu. If you're on OS X MacOS, you create a file in etc resolver. The name of the file has to match the domain name, the top-level domain name you've chosen for your network. Has to be exact, because that OS X uses that name to figure out what domain you want to use for your DNS server. So the name's important. And in there, we just tell it where our DNS server is. Same thing, just IP address. It's the IP address of our network lead, and that's it. Almost. Docker for Mac, there is an extra step that's needed to get all this stuff working, to bridge between the host operating system and your Docker environment on Mac. But I've got a whole section of the talk about that at the end, because otherwise it's a tangent at this point. But we'll get into that towards the end. But once you've done all of that, we can now ping our containers by name. And any containers we add to that network, you'll be able to ping them with no further config required, which is really bloody helpful for dev work. And how do we know what the name is? Well, we explicitly define it in our Docker Compose file. We say exactly what names we want that container to respond to. And what happens is Docker, behind the scenes, rewrites the host file on each of the container images that are running. And I've configured DNS mask to monitor that and pick up those changes and share them automatically. So you get all that for free. You just make sure you define them. Now, it's quite a lot there to do, but it's a one-off task. You set it up once, and it's sorted. You never have to revisit it as long as you've got that environment there. And with a bit of practice, you can have this up and running. I mean, the longest thing is rebooting Ubuntu if you're using Network Manager for resolving DNS. That's really quick otherwise, with a bit of practice. So that's how you set that up. And that gives you an isolated network with full DNS working, where you can put whatever containers you want and access them normally, the way all your tools expect. Whole classes of problems have completely disappeared because all your tools will expect to be able to talk to things over the network. Which means then we can start doing things we're being paid to do, which is the things that help us actually develop and ship code. So it's a good idea to add a database server. Most of us, I imagine, if not all of us, work on applications that are backed by a database of some kind. So let's stick something in here. The good news is this is easy. We've done the hard work. At this point, it's just a container. We're just throwing containers in. And here's the config for a MySQL container. We've got an image that we download. MySQL, Oracle kindly provide official images you can use. They work well enough. It has an environment stanza where you can set the password and which host can access root as well. Because your machine, your Docker network is completely isolated from the outside world, it's safe to say, let any host in. It's fine. It makes it easier for your host to get in there anyway. We're mounting some volumes, which we'll look at in a moment, and we just define it on the network. This is something you can literally cut and paste in, and it will work just fine. And I mentioned some folders. Remember where I said create the structure for the network lead? Do the same for the MySQL. Create another folder for MySQL and put these 3 folders underneath. And then we mount them into the image. We mount in the data because we want our MySQL database to actually write its files to our host operating system. So when the container is gone, or we destroy it because we're upgrading to MySQL 8, for example, because that looks exciting when that comes out, we don't want to lose our database. We want any logs, like our slow query log, etc., to be written out to the host operating system, so we can take those apart and see what indexes we're missing. And if we need to inject any config to switch on things like slow query logs, we can easily do that by injecting our own MySQL config file. We just chuck it in, and we're sorted. I really want to make this point. The whole reason for these folder structures, which I don't see other people talk enough about, is because what are you going to lose if you destroy, not if, when you destroy the container? Containers are meant to be temporary. They're meant to come and go. And in a dev environment, hopefully you're upgrading your containers periodically to pick up new releases with new features, new security patches, all that sort of thing. If your containers are configured to write inside themselves, the data they write in there, their logs, their config, sorry, not the config, their logs, their databases, etc., will disappear completely. And that can be a problem. In fact, it should be a problem, to be honest. So this structure gets rid of all of that entirely. And any third-party containers you're looking at, look to see if they follow that pattern. Can you tell it where to save the data to? Can you tell it how to inject config? Not just via the environment stanza, but how to inject its own config files if necessary. Can you make it log to the file system? The Docker convention is everything logs to standard out. I don't know about you, but my apps log a shitload of stuff in development so I can see what I'm going on. I don't tend to use debuggers because you can't use the debugger in production. So I use logging for everything because I know if I have a problem in production, I've got the information I need to fix it. I can't run a debugger in production. Those logs can get quite big when everything's switched on. So I want them written to disk so I can load them up in a text editor and study them properly. Having something stream past the screen and lost forever because it's just gone to standard out doesn't work for me. So write everything to disk. There's a lot more to do with container design than this. And originally when I pitched this talk, I was hoping to do a whole section on that. But we're already 42 minutes in. Or 2 hours, it might be feeling for some of you, I freely admit. And I realize that container image design really needs to be a talk in its own right. It's a huge topic to talk about why we do things, because we don't just write to the host operating system's file system to preserve data. There's other reasons we don't write inside containers that are also important. But there's too much to go into in one tonight. So I will do that in a separate talk. I will video it, and hopefully it won't be a mime show. Hopefully all the mics will work. And that will go up on YouTube somewhere, and I'll make sure the user group gets that so you guys can watch it at your own leisure. And I might even try and get it transcribed into a blog talk so you don't have to watch it, which might be preferable, I admit. Okay, but coming back to today then, we're going to start our MySQL container. There's no surprises here. It gets the next available IP address. It's up and running. And to make sure it always gets that IP address, because we don't want it getting the O2 IP address when we restart everything all at once. Because in our host operating system, we've configured DNS to always look at O2 as a static IP address to go and do DNS resolution. So we don't want MySQL to sneak in there. So we don't want MySQL accidentally getting the O2 address. And that's what this depends on section in the service definition is. We're telling Docker Compose, don't start MySQL until network lead is up and running. And that's how we guarantee the order of IP addresses. And the nice thing about this is we don't have to try and remember what order everything should come as a whole. We just say MySQL, it always needs DNS up and running first. It doesn't need to know about anything else we put in that config file. All it needs to know is, give me DNS first, don't screw that up. And once that's running, you can just access it as if it's a real database server on a server somewhere else. All your tools just work. It just makes life so much easier. And that's how you set up a database. Does that seem reasonable so far? Has anyone who uses Docker seen anything objectionable to setting up a database server that way? No? Sort of. You've got experience I can learn from as well, don't forget. OK. You're not looking convinced. Oh, dear. Fifth and final step, setting up applications. That's just as easy. It's the same approach as with MySQL. I actually have already built an image that it's built on Ubuntu, has Nginx and PHP FPM all configured for development. Because Ubuntu ships with 7.0 at the minute, it uses PHP 7.0. I will be maintaining that as Ubuntu catches up. My experience is my clients tend to stick with the LTS versions of Ubuntu. It's just easier for them and their skill levels, and the fact they don't work with this stuff all day, every day. It's something they dip into. So bleeding edge for them means a lot of breakage, a lot of things they have to go and fix that they don't necessarily know how to research straight away. So that takes time for them to learn that stuff. Whereas with LTS, things just don't break, and it just makes an easier life for them. And because it gets all the security patches that they need to stay safe, everybody's happy. We're mounting several volumes. But we're mounting 4 volumes this time. So we're mounting config, data, and logs as before. Config's obviously optional. But we're mounting this other one as well. If memory serves, it has been a few years, as you saw earlier. You have the /Vagrant mount, don't you, when you use VirtualBox with Vagrant. And I believe it also creates a /Workspace mount. I've certainly seen that in some places. And that's where that idea comes from. What I'm doing is I'm importing the whole project structure under /Workspace inside that container. So the whole project structure is there. And you can be stricter with this. You could just make it load the My App itself under there if you wanted to. You can be as strict as you want. So just to show here, we're mounting that project there as /Workspace, which means any container can have access to all the files underneath if you need it. And you can tighten that down to just say, well, just mount My App instead. Now, there's a default site configured with Nginx, and it just needs to know where's the document root for your HTML files, or hopefully your front-end control if you're using a modern framework. But obviously, there's a lot of PHP apps out there aren't built with the front-end controller style, and they're just as valid. And to be honest, they're way more popular. So there's a config environment variable there to inject in. And if you need to, you can change the timeout between Nginx and PHP. If you're debugging some code that needs some indexes and you try and track down what's going on, being able to override the timeouts can be handy for that. We just tell it, start DNS, start the database first. That's it. We fire up our app, and we're done. We now have a working PHP app. There's nothing else needed. I mentioned WordPress. I have built an image for WordPress as well, if you need it. I need to update it to 4.8. I haven't touched it for a few weeks, but I'll get that done. This one can do a few more fancy things, because one nice thing about containers is you can put startup scripts in them. So this particular container is configured to go and download themes if necessary, and go and download any plugins you need from as well. And if you're giving containers out to other people in a dev team, especially developers who aren't as comfortable working on the server side of things, being able to say, we're going to get all these things for you, so you're starting up a standardized environment, can be really handy. And we've had a lot of success with that. And the nice thing is, you can run both if you have to. So if you've got WordPress and you've written a custom plugin that's talking to a custom app that's providing data, for example, you can just run both. You can run whatever you want in this environment. If you want to run RabbitMQ in there for asynchronous tasks, which is something I'm doing at the minute, you just add it to the list. You can run whatever you want. There's a Docker image for just about everything. And if you find something that doesn't yet have a Docker image, it's not a lot of work to build one. And then you can chuck it in there, and you can run whatever you want, all isolated on the network. They can all talk to each other, and nothing else can interfere with them. It's really nice. And in case anyone's interested, we've started a database server, we've started some PHP. How do they talk to each other via PDO? You just give it the host name that you've defined in your Docker config file, your docker compose.yaml file. I leave the network off because they're all on the same network, so you don't need to use the top level domain. You just do that, and off you go. That's it. That is how I build PHP dev environments. I use Docker Compose. I use networks. I put the containers on the network, and I have a special container that goes on the front to provide my DNS services. And then I make sure for my host operating system, DNS is resolved onto each network in turn, so I can access it from all my tools. What do you think? Have I convinced anybody? Is anyone going to leave here and next week convince their boss, or if they are the boss, decide that we're going to do something like this? It may not be identical, but that you've got something here that you could copy and start from in order to do it yourselves. Anyone convinced? No?
I've already tried to start on that, but I'm going to take the old pattern of the folders, because I don't actually do that at the moment. I keep counting log volumes, you forget, and then counting them, and you realise no home.
So that's one of the other reasons I like about using Docker Compose for this is you put it all in there, and then whenever you start up your environment, they're already mounted every time for you. And one of the interesting things about Docker is because it runs as root with all root's privileges, it will create all the other structures underneath those that it needs. So you can give it an empty MySQL data directory, and the MySQL instance will come up. It will create all the subfolders it needs, create all the files, do all the MySQL initialization for you. You can start off with an empty folder, and it will just work. You occasionally find images that don't do that reliably, but that's more the app than the container itself, I find. Yes, please. Oh, sorry, at the back.
I've seen various open source projects that have Docker containers you can download.
Yep.
You just download it and put it in the file system.
Yes.
Yeah.
I do exactly that. So I showed MySQL. I'm using the Docker container built, the Docker image built by the MySQL team. I don't build my own. I'm using something called MinIO at the minute to give me the local equivalent of Amazon S3. So I can do dev work while I was on the train on the way up, in fact. And I downloaded their image as well. So I would do that. Where you're taking someone else's packaged app, their service, definitely. For PHP, use mine as a starting point. You may want to change it, you may want to improve it. You tailor it for your own needs as well. It's a good idea to get your hands into building your own Docker images at some point, just so you're familiar with what's going on and why. Does that answer the question?
Yeah.
Okay.
With multi-build on PHP now, you can also sort of take that and just build on top, as it were.
Yes. Yeah. And you can build on top of my images as well. That WordPress image is built on top of the generic dev image. It just injects some extra Nginx config for WordPress and WordPress multi-site as well if you use that. Anyone not convinced? Anyone looking at this and going, it's not as easy as I was hoping, or that's a bloody mess? Anything like that?
How long does it take to spin up those?
It takes to spin up 2 or 3 seconds, tops. Yeah.
What sort of memory footprint?
Same as running it native on the host operating system. The container has virtually no overhead in that respect. My containers have a little bit more because I actually run multiple services inside each one. That's really one for another talk, but I don't agree with the idea that of just exactly one service per container, because in reality, when you're building a box, you're often running several daemons together to provide a single service to the outside world, and that's how I package my stuff up. So my Nginx and PHP are all in one container. I don't get people who run Nginx and PHP in separate containers. You'd never put Nginx on one Amazon box and PHP on a different Amazon box and have them talk to each other. So I lump them together for that, and I use Supervisor to control it all, which means my images are really easy to tailor. And if you wanted to, you could even drop SSH onto my images without breaking anything that's already on there, if you wanted to log in directly and see what's going on inside the container for debugging purposes. I don't need to do that, but if anyone did need to do that, it's trivial to do. And it's something make it your own. You find a shape that works for you, your team, your organization, and you stick with it. A lot of the advice out there is from the early Docker days, where isolate all the things. And it's like systemd all the things. It's a good idea taken too far. Be pragmatic. Build what you'd build if you didn't have containers, if you had real servers. And at that point, everything else is built for that world of real servers, and it all just works.
What do you do about SSL?
What do I do about SSL? At the minute in my dev environment, I do nothing about SSL. Because obviously if you're creating certificates with Let's Encrypt, it can't connect back in directly to verify. Now that's where a commercial tool called ngrok. Anyone heard of ngrok? Yep. It's invaluable for punching holes through firewalls and everyone else's security. But you can use that to create a tunnel in. So if I've prepared a new data load for one of my clients, I'll sometimes set a tunnel up so they can come in and see my environment before I upload it to theirs. So they can go, well, hang on, that import's not gone right or whatever. And you could do the same to Let's Encrypt in if you wanted to create certificates. But at the minute, I don't. But that's partly because in production, I encrypt at the firewall. I don't encrypt on the servers myself. I remember the days when we used to have to buy special hardware to do SSL because CPUs weren't fast enough. Yeah. So I'm in the habit of my edges being where the SSL terminates, which is not a good habit in today's world, I freely admit. I need to update my own practices there. Does that answer the question? Awesome. So, any more thoughts on dev environments? Good, bad, indifferent? You're a tough crowd. You really are. So, is anyone doing it radically different? I mean, you've mentioned defining the networks in the Docker Compose file.
Yeah.
So.
I'm not a big fan of using volumes.
Okay.
I like to use named volumes if I have to.
Right.
And I've moved away from mapping volumes to a host.
Okay. Be very interested to hear why.
Because then you're tied to a single host.
Right. But for a dev environment, that's not a problem.
Yeah, obviously for a dev environment.
Yeah. Yeah. And these are definitely dev images that I've shared. You can run the MySQL one in prod, but I mean, this is where I don't have the experience really at the minute about production and what to do with volume management and all the rest. So I don't have any insights into that. All I will say is the moment you start your container starts writing to its own internal file system, you're in a world of pain. Most containers still use OFS, the copy on write file system, AUFS, because overlay and overlay 2 are a nice, interesting collection of bugs and not much else. But AUFS is also an interesting collection of bugs. and its write performance is terrible and it rapidly falls off a cliff. You run Graphite is the perfect use case for this, something that collects metrics in real time. You hit Graphite, you put a Graphite server entirely in a container right into its own file system, you will trash Docker completely, because you'll trigger so many AUFS bugs from how much you're hammering it, you'll knock the whole thing over. So that's one of the reasons I always write to an external file system with that.
I'm not saying it shouldn't have volume, I'm saying I don't like to have the mapping.
Right.
I like to have a named mapping.
Okay.
Just a name, not a path.
Right. But that would require setting up volume containers, wouldn't it? How do you do that then?
It's done.
So where is the volume?
So you have to do Docker inspect, and then you can get the actual path
Right.
installed in the Docker bar.
Okay. Right. I'd love for you to share some examples of that, because that's not something I know much about, and I'd love to learn more. I've gone for stuff that, for me, keeps it all in the same folder. That whole project's in one folder. 'Cause when I finish with a client, my last task with any client is to nuke that environment completely. If I'm no longer working for them, that's no longer my property, it's theirs. And it has to go, it has to be archived, removed, whatever, because I've moved on to another project. So having it all self-contained within that one My Project folder, for me, works really well. But I work with multiple clients, and some clients have very sensitive data. I mean, one client I'm working with at the minute, we're looking at a GDPR solution. So you've got to be able to have the practices in place to give confidence with that. Yes, please.
One of the reasons I've not fully moved to Docker yet is because I use a Mac.
Yeah.
I heard it can be really slow on the Mac.
Right.
And do things like Docker Sync,
Uh-huh.
which I've not used yet. Or some people have written custom solutions where they keep on copying things over to Docker.
Well, do we all want to grab a slice of pizza, and then while you all munch, I'll talk about Docker on Mac versus Docker on Linux, so that the pizza doesn't go cold? How does that sound? Does that work for everybody? Yeah. Awesome.